In part 1 of Basics of Phaco, we talked about the different pump systems. In part 2 of Basics of Phaco, we talked about the energy delivery inside the eye, mainly the stroke length and frequency. Continuing our Basics of Phaco series, in part 3, I'm going to talk to you about the different modes of energy delivery inside the eye. Welcome to Basics of Phaco part 3. So in part 2 of the Basics of Phaco series, we talked about that ultrasound energy delivery is largely a function of two things, and that's basically the frequency of the phaco handpiece and the stroke length of the phaco handpiece, of the phaco tip rather. And we also learned in Basics of Phaco part 2 that frequency of the handpiece is fixed. When you increase the power, when you increase the percentage of power delivered inside the eye, what you are increasing is the stroke length that the tip travels inside the eye. But if you decrease the power, you're actually decreasing the stroke length that the phaco tip traverses or travels inside the eye. So now let's talk about the different ways of delivering this energy inside the eye. And the different modes of energy delivery inside the eye are: you can deliver this energy, you can deliver power in a continuous fashion, that is, the power, as soon as you go to Phaco III, the power is activated and it goes on as long as you do not take your foot switch back to foot switch position 2 or 1. The other way of delivering is pulse, and still another way of delivering is the burst. So let's first see what is continuous power, and we will also see the components of the continuous power. So in continuous mode, the delivery of phaco power is continuous, that is, there's no rest time. As long as you are in phaco foot switch position 3, the energy delivered inside the eye will be in a continuous fashion. That continuous fashion could be fixed or it could be linear also. So here you can see 40% phaco power delivered inside the eye in a fixed mode. That is, the moment you are there in foot switch position 3, 40% of your total stroke length is delivered inside the eye. However, in this example where you have a linear mode chosen, as you go to foot switch position 3, you are in the start of foot switch position 3, you may get a phaco power of 5%, 4%, or 3%, wherever, depending upon wherever your foot switch position is. As you press harder the foot switch, the stroke length will be more. That is, the energy delivered inside the eye will be more. That is, you will now get more and more power. So the more you press on foot switch position 3, as you go deeper inside the foot switch position 3, foot switch, you will then deliver more and more power. And that's what we call as linear. If you have chosen 40% phaco power, 100% is what you can maximum get. But you can set that what you want to achieve in the last of foot switch position 3 in a linear mode, what you want to get, you can set there in the panel. If you want to set 40%, then at the last of foot switch position 3, you will get 40% of that stroke length. If you have set 50%, then at the last of foot switch position 3, you will get 50%. But then in the start, you get 1%, 2%, 5%, 10%, and as you go deeper, you get more and more power. So in these two examples, again, just to repeat and what we have covered in the last slide, you have 50% of power selected in fixed mode, that is in the panel. Before you have entered the eye, you have set 50%, that is the moment you are there in foot position 3, you get 50% of the total stroke length. As you go, press harder and harder, deeper and deeper you go in foot position 3, your percentage of delivery of power inside the eye does not increase because this is on fixed mode and you have selected 50% of this total stroke length to be delivered inside the eye. So this is basically fixed mode. The moment you press foot position 3, you get 50% of energy. In this example, you have selected a linear mode of energy delivery inside the eye. So in this, as you press foot switch position 3, in the start of foot switch position 3, you start getting 10, 15, 20%. And then as you reach the end of foot switch position 3, you get 85% of your total stroke length because that is what you have preset in the Phaco display in the panel. However, note that both these are actually forms of continuous energy delivery. That is, the Phaco tip has no rest period. As long as you are there in foot position 3, the Phaco tip will be traveling and delivering energy in a continuous fashion. That could be fixed, that could be linear, but the energy delivery inside the eye will be continuous. So now we discuss about the pulse mode of delivery, of energy delivery inside the eye. In continuous, as I said before, the Phaco tip does not rest. However, in pulse mode, there is a resting period for the Phaco tip. The pulse mode can again be fixed or linear. So here basically what you see is a display of the pulse mode in one of the Phaco machines. This is what you have selected. You have selected pulse, Phaco pulse per second as 10, that is 10 pulses per second. You also have the option of selecting the on time, that is what period of time that Phaco tip will be on. So here you have selected 40%. That is 60% of the time the Phaco tip will be off. And what you see here is 50% that of stroke length you have selected on a linear mode. That is the length of the tip traveling inside the eye. So this is the stroke length, 50%. So if your Phaco tip total stroke length is 100 microns, then you have selected 50% at the end of foot switch position 3, that is 50 microns. So when you press the foot switch, you go deeper inside the foot switch position 3, and touch the bottom of foot switch position 3, you get 50 microns of stroke length. This is, however, the pulse per second. How many pulses will be there delivered inside the eye per second? And what would be the on time? Because you know, as I said before, pulses will have a on and an off time. So what percent of time will the tip be traveling and what percent of time will the tip be resting? So 40% you have chosen over here. That means the tip will be resting 60% of the time. So in this picture, you are seeing on and off times. Again, on and off. So the height of these bars is basically signifying the stroke length, that is the tip traveling. How far is the tip traveling inside the eye? That's the stroke length, right? We discussed in part 2 of Basics of Phaco series. And then what you are seeing this, the bars over here is basically the pulses being delivered. But remember, one pulse is the on and off time together. One pulse does not mean on time only. So the phaco tip travels, goes 50 microns, comes back and rests. So the traveling time, that is the on time, and then the resting time, that is the off time, together makes one pulse. So when you choose 10 pulses, that means in 1 second, the phaco tip will travel, come back and rest, travel, come back and rest 10 times per second. How long will it be traveling and resting will depend upon your on time, the pulse on time. That is, when you have set 40% on time, the 60% will be automatically the resting time. Here, however, what you can see is that the on and the off time are almost same. So it looks like a 50% on time and 50% off time. So let's take this example. You select one pulse per second. That is awfully very low pulse, but just for the matter of understanding, sake of understanding, let's take it as one pulse per second. Now in 1 second, how many milliseconds are there? There are 1000 milliseconds in 1 second. So one pulse will be delivered for 1000 milliseconds. That means the on time and the off time together makes one pulse. So the on time and off time together will be for 1000 milliseconds. So one pulse will be delivered for 1000 milliseconds. That is, again, I repeat, the on time and the off time, one on time and one off time will be together delivered for 1000 milliseconds. So how long will be the, if you have a 50% on time, then you have 500 milliseconds of on time and 500 milliseconds of off time here, right? Because you select, I'm taking the 50% on time, one pulse for 50% on time. So one pulse is delivered for 1000 milliseconds. 50% is the on time. That means 500 milliseconds will be on time and the rest 500 milliseconds will be the off time. In this example, I have taken one pulse 30% of time. So one pulse will be delivered with a 30% on time. That means 70% will be the off time, right? So again, one pulse will be, you have a 30% on time. I'm sorry, this bar is not visible over here. So you have 30% on time and then 70% off time. So you have a resting time for the tip, right? So one pulse for 1000 milliseconds, that is the one on time and one off time is for 1000 milliseconds. And we know 30% of the time it will be on. So 30% of 1000 milliseconds is 300 milliseconds. That's basically the on time. So in this slide, I will try to visually make you understand what these numbers mean. So you have 10 pulses per second, 40% on time, 50% is the stroke length on a linear mode. So if you think of, and if you take the example of woodcutter that we took during the part 2 of Basics of Phaco series, 50% stroke length is the distance that this cutter is going to travel before it hits the tree, right? The more it travels, the more the energy is delivered to fell the tree, right? Pulse per second, 10 pulses per second means the man has, in 1 second, he has to actually hit 10 times. That's quite impossible for human beings, but the machine can do it. The Phaco machine can do it, right? And then the on time signifies what would be the time that is taken to hit this tree and come back, and then rest also. So 60% of the time will be the resting, and then before again it starts traveling to hit the tree and come back, and that will be 40% of the time. 60% of the time will be the resting time. So as you can understand from this real world example, that it is a matter of combination of all these that will efficiently deliver energy inside the eye. If one of these components is just too big or too small compared to the others, it will not bring in the desired result. So all this, the distance that the cutter travels, the time that he takes to rest, as well as the number of times that he hits, will always have to be in synchrony so that energy can be delivered in a well-mannered fashion inside the eye, so that in the least amount of time the nucleus can be broken and emulsified. So friends, in this example, you see 20 pulses per second and the percentage of on time is 30%. And now I think you will do the maths very fast. So 20 pulses is delivered per 1000 milliseconds of time, because 1 second is 1000 milliseconds. So each pulse is delivered for 50 milliseconds of time, because 1000 by 20. 20 pulses per 1000 milliseconds. So one pulse is 1000 by 20, 50 milliseconds. So one pulse, therefore, that is one on time and off time, is delivered for 50 milliseconds. Remember, the definition of pulse is not just the on time. It is the on plus off time is what makes a pulse. So in this 50 milliseconds, you have 30% of on time and 70% of off time. So 30% of on time of 50 milliseconds is 15 milliseconds. So the phaco tip will be traveling for 15 milliseconds and the phaco tip will be resting for 45 milliseconds. So the rest period is more. And what does this 45 milliseconds of resting time help to achieve? It helps to keep the phaco tip cool. And also remember, phaco is done with a jackhammer effect. And we discussed this in part 2. So when there is a jackhammer effect, there will be some amount of repulsion and chattering. So that resting time helps the nucleus pieces to build up and come again back to the tip. So it helps the fluidics to build up. It helps to improve the followability. Now friends, in this slide, I'm going a little deeper, and this is because I've seen people getting confused between frequency of the handpiece and the pulses of energy delivered inside the eye. So in part 2 of Phaco Basics series, we talked about what is the frequency of handpiece, and we talked about that most handpieces would be around 40,000 kilohertz. That is, per second, they will vibrate for 40,000 times, 40,000 cycles. So every second, the piezoelectric crystals that are there in the handpiece will make the phaco tip vibrate for 40,000 times, or 42 kilohertz or 40 kilohertz, depending upon the make of the handpiece. Now people get confused with the pulses. So I will do the maths here for you, how the pulses actually is delivered taking into account the frequency of the handpiece. So remember in the last example, we talked about the 15 milliseconds will be the on time with 20 pulses per second and 30% of on time. 15 milliseconds will be the on time and 45 milliseconds will be the off time. If you didn't understand the maths, please go back into the last slide and revisit the maths, please. Now, in this 15 milliseconds, friends, the frequency of the handpiece also will be delivered. That is, the phaco tip will vibrate in this 15 milliseconds for its designated amount of cycles. That is, in the 1000 milliseconds, friends, the phaco tip, that is in 1 second or 1000 milliseconds, the phaco tip is designed to vibrate 40,000 times, isn't it so? Therefore, in 15 milliseconds, the phaco tip will vibrate 60 times. So we know the on time with 20 pulses per second, 30% of on time. The 15 milliseconds will be the actual absolute on time. And in that 15 milliseconds, the phaco tip will vibrate 60 times or 60 hertz and then stop for 45 milliseconds. Then again it will start vibrating 60 times within the 15 milliseconds and then stop vibrating. And why will it stop vibrating? Because we have chosen an off time of 45 milliseconds so that the phaco tip gets cooled and also the fluidics built up. So this is how basically the pulse worked in conjunction with the frequency of the handpiece. So friends, the purpose of discussing in detail the pulse is to help us understand that it's not just increasing the pulse per second or decreasing the pulse per second which will help you to emulsify the nucleus efficiently. You have to understand the grade of the cataract and then accordingly select the number of pulses per second you are going to deliver inside the eye. That is the how many times the cutter is going to strike the tree within that particular time. What would be the on time and what would be the length of the cutter, that is 35% or 40 or 50% of the stroke length. So what would be the distance that this cutter will travel is the stroke length, how many times it will actually be striking the tree within a particular time. That's basically your pulse per second. And how long is it going to travel and come back is going to be your own time before it rests. So this combination of all this will help you to emulsify the nucleus piece properly in the least amount of time. Also remember, there has to be a healthy balance between the energy delivered inside the eye as well as the fluidics used inside the eye. If you deliver less power inside the eye, but you take a long time and there's a lot of irrigation and aspiration going on and on, a lot of fluid used, then it doesn't help. So there has to be a healthy balance between the phaco energy delivered inside the eye and the least amount of fluid also used for the least amount of time. Just a quick note, remember, just like in continuous power, you could deliver the power in in linear mode or in fixed mode. So also you can do it in the pulse mode. So for example, remember the stroke length we talked about in the pulse mode, you can also have a linear stroke length, or you can also have a fixed stroke length. Of course, you choose the linear stroke length of pulse or fixed stroke length of pulse in conjunction with the on time and the pulses per second. Thank you very much for your for following my channel, and if you want to visit quickguide.org, you're welcome. Please subscribe and keep getting the updates.